Hi guys. Good afternoon. I was 10 minutes late because I could not find, there was some problem happened. Right. I could not start the class due to some technical problem early. Right. Now it's resolved. So is audio video both are clear, everyone? Audio and video both are clear, all of you? Right. So we'll be going for which one? This is a new subject now. Already we have completed this steel structures at Brahmastra batch 2. For this steel we have done already. Now we'll be going for this structural analysis. So this is the first class on this structural analysis, we can say, right? So congratulations for ESC 2023 toppers, right? Those who cracked it. Yeah. Yeah, actually Unacademy app link is not there. Unacademy, it is not happening in Unacademy app. Yeah, Ashwin Babu, it is happening only in which one? This YouTube today, okay? So this class, YouTube only today, and the next two classes will be in the special classes, Unacademy link, and the next fourth class will be in the YouTube, right? Like that, one class will be in YouTube, next two classes will be in the Unacademy app, one class will be in YouTube, next two classes will be in the Unacademy app, right? Like that it will be happening, okay? Right, Ashwin? So Unacademy link is not there, okay? Only in YouTube it is happening, right? Now at present this wonderful offer is going on, everyone, that 50% discount you can get on your subscription amount along with 4 months subscription. So the 6 months, if you take 1 month extra, 12 plus 2, 15 plus 3, 24 plus 4. So like this you will be having which one? This offer, right? So don't miss this opportunity, everyone, right? So you can save up to 50%. So these are the features for this plus subscription, and these are the features for this iconic subscription, right? And what is it? A referral code you have to use always, all of you. That RP will, I think it is not visible for you, right? Backside, my backside it is there, na? Okay, RP civil is the code you have to use always, right? So what is the referral code you have to use? RP civil, right? And geotechnical engineering will be started on November 30th, right? So Brahmastra plus batch will be there for gate 2024 civil, right? Geotechnical engineering by Amit Jarralo sir will be starting. So don't miss this opportunity, all of you. So RP civil is the code you have to use, okay, when you are subscribing. So this is also mission batch for this 2025 also will be starting. Geotechnical engineering at 6:30 p.m. right? It will be started. First batch you can say, right? So these are the list of books. Those who are having this iconic subscription, they'll be getting these books within 15 days of your subscription. And those who are unable to pay this entire fate time now, you can just go with this no cost EMI option, that too with the 0% interest on your EMI, right? These are gate 2023 toppers. Congratulations all of them. Now coming to our discussions, right? What is it you can say? Structural analysis. These are all the topics you are having, okay? These are all the topics you are having. Yeah, Ashwin Babu, I did not forget, I told you, no? So one class will be in YouTube and the next two classes will be in the special, right? Okay, like that it will be there. Now we'll be going for this introduction to structures, right? So shall we enter first chapter? That is chapter 1, introduction to this not a steel structures, it is structures, okay? Introduction to this structures only, right? Not steel structures, right? You have to be careful, right? So shall we start? Shall we start, guys? Right, I'll be starting if you just observe. Now, starting with the structure and mechanism. So there is a difference you are having if you just observe. The basic difference between which one? This is structure and the mechanism, you can say, right? So when you observe a structure and when you observe a mechanism, what is the basic difference between them? Tell me, anyone? When you are observing a structure and when you are observing a mechanism, right? What is the basic difference between these two? Everyone. The basic difference will be, right, like what? Structure will be resisting the loads or it will not be resisting the loads, tell me. Structure will be resisting the loads or it will not be resisting the loads, right? It will be resisting the loads, no? Yeah, I think in that yeah, good afternoon, Shubham Kumar, Shruti, Ashwin, everyone, right? All of you had your lunch or not? So if you just observe this is structure, right? What is that structure? You can say, I don't know why this backside it is happening like that. Okay, let it be. So structure, if you consider, what is that you can say? This is your simply supported beam, na? Yes or no? This is your simply supported beam, and whenever you are applying the load, it will collapse or it will not collapse. Tell me. That will never collapse. Na? Now if you observe a mechanism, same simply supported beam, but what you will do, we will consider an internal hinge, right? Simply supported beam with an internal hinge. If you apply, what is that load, you can say that 0.00001 kilonewton if you apply, na? So still further to load also it will be subjected to which one? This collapse, you can say. Okay, but that one it will never collapse, right? It will be resisting the loads, right? So that's why the elastic profile comes in that manner, right? So what this structure will do, it will resist the loads or not? It will resist the loads definitely or not? Yes, it will resist the loads if you just observe, right? Now what is the mechanism? It will resist the loads or it will not resist the loads, you can say, right? It will never resist the loads, na? It will not resist the loads, right? And the second point, if you just observe, so what is it you can say? What is it you can say if you just observe, right? So the elastic curve, right? What is the meaning of this elastic curve, you can say? Elastic curve is nothing but your deflection profile, na? What is the elastic curve, everyone? Elastic curve is nothing but your deflection profile. So how is that deflection profile or this elastic curve? Tell me. Elastic curve is which one? This is a non-linear. Okay. Elastic curve is a non-linear. Here what is that you can say? Elastic curve is linear. Okay. Elastic curve is which one? This is linear, you can say, right? Now what are the other points we can write under these two if we just observe mechanism and this structure? So this structure can be converted to mechanism, right? You can convert this structure to which one? This is a mechanism, right? How can you convert? This structure can be converted to this mechanism, right? How it is possible? Tell me, everyone. Even is it possible to convert a structure to mechanism, or it is not possible to convert a structure to mechanism? All of you. Is it possible? Conversion of a structure to mechanism, it is possible or not possible? All of you. Tell me. Yes, it is possible, right? Yes, it is possible, right? How it is? How it is possible if you just observe, right? Now same, you take the simply supported beam only. The central point to load, if you consider, na, the central point to load P whenever you consider, right? What is it you can say? The bending moment diagram, right? What is the bending moment diagram you are getting? The bending moment diagram will be like this, na? This is your PL by this 4, right? So as this P value gets increases, right, what happens, you can say? As this P value increases, right, this bending moment value also will be increasing, na? So once the bending moment, right? So how it will be converted? If the bending moment, right? If the bending moment is greater than the moment of resistance of this section, so if the bending moment is greater than the bending moment applied is greater than the moment of resistance of this section, it will try to collapse, na? That plastic hinge will be formed at the maximum bending moment location, and all of you, right? So that is how you can convert. That is how you can convert which one? This is structure into this mechanism, right? So is it possible to convert a mechanism to structure, everyone? Once it is a collapsible form, we cannot convert it into structure, right? It can't be converted. From where to where? It can't be converted to which one? This is a structure. That is what you can say. It cannot be converted to which one? This is a structure, you can say, right? Note it and tell me, everyone. Just observe. Video gone? One second, guys. Let me check it. There you are. 1 second. Arre, what happened? It has got stuck. I don't know how to do this. Still it is get stuck. Can you able to have my audio? You can listen to my audio. 1 second, I'll just close and open. I'll try to close and open. Just a minute, just a second, all of you. It may work out. It may work out. 1 second. Arey yaar, what happened? Now it will work out. Yeah, now it's okay, everyone. I think now it will be working good. Definitely, it should be right. Okay. Now video also okay, right? Right. So here it is possible to convert convert a mechanism to a structure, or it is impossible to convert a mechanism to a structure, right? It is impossible for a mechanism to be converted to a structure, right? We can never convert a mechanism to a structure, right? Because once it is collapsed now, once it is in the collapsible format, it's impossible, you can say, right? It is very, very impossible, you can say, right? Now coming to this, noted everyone? So noted all of you? So then I'll be moving on to the next one, that a classification of these structures, you can say. So what is the classification of these structures if you just observe? So there are different classification of these structures, right? What is that you can say? First one is your skeletal structures, right? What is the surface? What is the structure you can say? Skeletal structure, right? What is the meaning of this skeletal structure? Skeletal means what? Have you ever observed your skeleton or anybody's skeleton? So what you can say, can you able to see the flesh and everything, or only just the bones you can see, right? You can just see the bones, na? Is that no? So this is your skeletal structure, you can see if you just observe. So here how many dimensions are dominating, tell me? How many dimensions are dominating if you just observe? Only one dimension is dominating, na? Yes or no? Only that one dimension is dominating, right? So here if you just observe, length is dominating, right? Other dimensions are not dominating, right? Here also if you just observe, right, what is that you are having? This is your truss, na? This is your truss if you just observe. That is also a skeletal structure or not? That is also a skeletal structure, na? Yes or no? So one dimension is dominating. So two dimensions are not dominating, na? Yes or no? Length is dominating, you can say if you just observe, right? Is it clear? Second one, right, what is it you can say? So what is the second one if you just observe? Surface structures, right? What is the meaning of this surface structures? What is the meaning of this surface structures? Tell me. How many dimensions are dominating if you just observe? That is your two dimensions are dominating, na? Yes or no? Two dimensions are dominating, you can say if you just observe, right? So what are these two dimensions are dominating, right? What are the examples of this one? You can say whenever you are considering a slab here, for this slab if you just observe, right? Plate, slab, whenever you are considering any shell type of this structure, all these will be which one? How many dimensions are dominating? Two dimensions are dominating or not? Yes, two dimensions are dominating. Then you can call it as the skeletal structure, right? Next, sorry, surface structure, right? Next, so we can find this area, na? Yes or no? Area we can find it, na? Surface structure. So there you cannot find the area, right? Here you can find the area, right? What is that? Another one you can say solid structures, na? So what is the meaning of this solid structures if you just observe? Solid structures means that how many dimensions are dominating, you can say three dimensions are dominating, na? Yes or no? Three dimensions are considerable or this dominating, right? So what are the examples of this one, you can say? What are the examples of this solid structure if you just observe? It is machine foundations, you can say. So whenever you are having these machine foundations, now right, this one you can have, right, this machine foundations will be there, and also along with that, right, what is that you are having? Retaining wall, right? Have you ever observed this retaining wall if you just observe of it? This is your retaining wall. This retaining wall is also a 3D type of the structure now, and a dam, very big dam you are having, right? So whenever you are come across a very big dam, na, that dam is also which one? This 3D structure, right? As now all dimensions are dominating, right? Like that. Okay, note this and tell me everyone. Note and tell me all of you. Note this and tell me. Done all of you? Machine foundation, right? The foundation which is provided below the machine parts, right? So that vibrating machines will be having a, so we'll be having some vibrating kind of machines na in your concrete laboratory, and wherever you go, these bada machines will be there na. Those machines will be vibrating a lot, so to take care of that much amount of the force, we'll be having this strong foundation na, that is machine foundation, you can say. Okay, foundations for the machine, right? Okay, note this and tell me. I'll move on to the next slide there. This is retaining wall. This backfill will be there na. This soil will be retained by this retaining wall. Dam, it will be retaining the water. Yes, surface structure, plate, slab, and which one? Plate, slab, and also what is it you can say? What else you are having? Shells, all these. So cooling tower, if you just observe, that cooling tower is also a type of which one? This is a surface structure only. Note and tell me. Done. Now coming to this third one. So if you just observe, there are different types of this supports. If you just observe. So what are these different types of this supports? If you just observe, right? There are different types of this supports, you can say. The first and foremost one is which one? This fixed support. No? Fixed support, right? What is a fixed support? If you just observe, right? Whenever it is a fixed support, na? So whenever it is a fixed support, right? How many reactions will be there? Tell me all of you. How many reactions will be there if you just observe it? So we'll be having this three reactions now. One vertical reaction, one horizontal reaction, and one moment reaction will be there, right? So how many number of reactions will be having for a fixed support, all of you? That number of reactions will be equal to 3. For which one? For this 2D, na? Yes or no? What are the three reactions we are having? Reaction Rx, Ry is the moment reaction, right? Moment reaction, right? Three reactions will be there, right? This is for which one? This is for this 2D structure or this plane structure, na? Whenever it is a 2D structure or this plane structure is there, we have to go for this or not? Yes, definitely. But if it is a space structure, how many reactions will be there? Tell me. For a space structure also will be having the 3 reactions only, or will be having more than 3 reactions? Tell me for the space structure. For the space structure will be having the 6 reactions. Is that no? What are these 6 reactions you can say? So these are your Rx, Ry, Rz. Next, what is it you can say? Mx, My, next Mz, right? So 3. If it is a space structure, right? If it is a space or this 3D structure, right? Whenever it is a space or this 3D structure, na, we'll be having this 6 reactions, you can say. Is it clear? Is it clear, everyone? Now coming to this, right? Next one, what is that you can say? What is the second one? Hinged support. Na? What is that hinge support? You can say hinge or this pinned support, right? Hinge or this pinned support, right? You can call it as the hinge support or you can call it as the pinned support, right? What is it you can say? If you just observe, this is how it will be there, na? So whenever it is a pinned support means, right? What is it you can say? Pinned support or this hinged support, right? How many reactions will be there if you just observe? Whenever it is a plane structure, right? How many reactions will be there? Number of reactions will be one vertical reaction, one horizontal reaction, right? Yes, now This is, so two reactions, right? If it is, which one is a plane structure, na? If it is a plane structure, right? And the number of reactions will be equal to which one? This is 3. If it is, which one? This is space structure, na? Space structure, or this is 3D structure, plane structure, or this is 2D structure, you can say, right? Now, got it? Now, what is the third one? If you just observe roller support, you can say. This is a space structure, na? This is a space structure. If you just observe, this is a space structure. Fixed support will be shown like that only. The showing of the fixed support will be same only, right? So this is a skeletal space structure, na? This is a 2D structure, you can say, okay? This is a 2D, or this is plane structure. This is your 3D, or this is space structure, right? Support representation will be same only, whether it is a 2D or 3D structure, okay? For whatever the structure, 2D structure, fixed support is like this, hinged support is like this. So for this 3D structure also, support representation will be same only. There is no change, okay? Roller support, whenever it is at a roller support, right? What is the, you can say, if you just observe. So only one reaction perpendicular to the rolling surface, right? Suppose if your roller is here also, what is that, you can say? Whatever the direction the roller is there, only one reaction perpendicular to the rolling surface, right? So what is that number of reactions? You can say that number of reactions will be equal to 1 only. That is for which one? This both plane and this space structure, na? For both plane and this space structure, right? So what is it, you can say, that is always perpendicular to this rolling surface or not? So if it is rolling in this manner, reaction will be like this, okay? Perpendicular to which one? This is a rolling surface, okay? Note this and tell me, everyone. Note and tell me, all of you. Second class, next class we will be starting which one? This static and kinetic energy, all of you. Yeah, Naveen, good afternoon. Note this and tell me, all of you. No. Same as steel only. What we have done, some sessions will be in YouTube, some sessions will be in special classes, okay? Continuation here and there will be shifting, okay? One session will be in YouTube, na? Next two sessions will be in special classes. Fourth session will be in YouTube. Fifth, sixth will be in the special again, okay? Seventh will be in YouTube. Eighth, ninth will be in the special, right? Like that will be there. One session in YouTube, two sessions will be in the special class. Note, tell me. Noted, everyone? Yeah, Naveen was asking, na? Yeah, special class is free of cost only. Special class means free class only, right? You just follow my profile, then you can find. I'll be sharing in the community the links regularly, okay? If you are following me regularly, you can find everything. Your message only coming, others messages also coming, right? You might have changed the settings, right? That's why your messages are not, other messages you cannot see. Okay, noted, everyone. Shall I move? Shall I move to the next type of support? All of you. So I'll be moving on to this next type of the support, right? Now, so what is that, you can say, next support? If you just observe this fourth type of this support. So these are the general regular supports we'll be having, we'll be seeing regularly. And what are the other supports you can see if you just observe? What are the other supports you can see if you, everyone, if you just observe? We can see the other supports like what? We can see the other supports like which one? This guided roller support. So what are these guided roller supports if you just observe, right? You can say this is how the support will be there now. Roller will be there, but what happens, guided roller, right? These kind of this supports will be there. Okay. So what is the difference between this one and that one? Here from the fixed support, if you allow the rotation, then it will become this hinged support, right? But here allow the rotation means movement reaction is removed, right? Here what is that we are removing? Here we are removing the vertical reaction, here we are removing the horizontal reaction. So movement reaction is not removed, right? You have to be careful, right? So what are the reactions we'll be having? One reaction perpendicular to the rolling surface, other one is your movement reaction. Here also one reaction perpendicular to the rolling surface, other one is your movement reaction, right? So now tell me how many number of reactions will be having? How many number of reactions will be having? Tell me. Two reactions will be there if it is which one? This is a plane or this 2D structure, right? If it is a plane or this a 2D structure, right? Now tell me how many number of reactions if it is a space or this a 3D structure. Anyone tell me? I will not tell you until I will not write until you are telling. Anybody tell me? You just guess and tell me how many will be possible for this. Guess and tell me, anyone, how many reactions are possible for this? Anyone? Try. Let's try on the similar grounds, right? How many reactions are possible? Tell me. For this supports. Tell me, anyone? Yeah, that is different, right? That is different actually. That is different actually. It is not amplitude based. So this is support, guided roller support only. I'm asking, right? How many reactions? Plane two reactions are there. So space you will be having one reaction only. Are how it is possible? How it is possible? Movement is not resisted. So what are the three movements possible? Tell me. Movement is not resisted, na? So what is it you can say? Mx will be there, My will be there, and this Mz will be there, right? Along with that, right, what is it you can say? Out of this three directions, right? So here you will be having, this is your space structure, na? Right? This is one direction, is not? This is one direction, this is one direction, is not? This is one direction, this is another direction, right? Okay, right? So what is it you can say? Where is that amplitude and this gap? Tell me, Naveen, is there any amplitude, is there any gap I have done? So that is you are talking about this shear key. Okay, that is different. That is different. Shear key support. Array. That is different. That is different. That is different. I am talking about, right? Whatever you are talking about is, Naveen, you have to be careful, right? Whatever you are talking about is this one. Okay. You are talking about this one. Okay. Understood? You are talking about this kind of support, na? This amplitude is equal to that gap. This one will come, right? Not for the fourth one, right? For this fifth one, whatever you are saying will come. Okay, you have to be careful. Got it? Understood? So how it is different from that? Okay, yes, na? That is different and this is different. And here, is there any gap? Here, is there any gap? Tell me. No gap, na? Yes, no gap you are having, right? So there were no gaps you are having, right? Reactions, how many reactions are possible? Tell me. That is what I'm asking, right? How many reactions are possible here? Here horizontal reaction is not there, right? Vertical reaction will be there, momentary reaction will be there, right? Here also momentary reaction will be there and vertical reaction will be there, right? So here what is that you can say? Perpendicular to this axis, right? Two shears. So guided roller support or shear release support, okay? Guided roller support or this is shear release support, right? Now you understand? And you tell me shears will be released, right? Shear reactions will not be there, right? So Mx, My, Mz will be there and axial reaction will be there, right? One Fy, okay, Fy will be there For this, let us say F axial you can say, right? Instead of writing FY, F axial will be there. That's it, right? Total how many are there? 4 reactions are there, right? 4 reactions are there if you just observe, right? Is it clear? Horizontal movement, vertical reaction, vertical movement, horizontal reaction. Okay, that is fine. But shears are released na. How many shears are possible? Tell me. 2 shears are possible. The son, how many shears are possible? Tell me. 2 shears are possible. There are not. Yes, 2 shears are possible if you just observe. Right? Is not. 2 shears are possible here. Right? 2 shears are released na. If you just consider for this fixed support, right? How many are there if you just observe for this? This is your, what is the concern? 2 shear reactions, 1 axial reaction, axial force reaction. 3 moments will be there, right? 3 moments will be there, and among these Rx, Ry and Rz, one is axial, other 2 are which one? This is shear, right? So these 2 shears are released. Only which one are there? Moments will be there, as well as which one is axial reaction will be there, right? Got it now, Shruti? Like that. So now sleeve support. So whenever it is at a sleeve support, right, what is that you can say? It will be releasing which one? This axial force release support, right? Axial release. So it will be releasing which one? Axial reaction will be releasing, and shear reactions will be there, and moment reactions will be there definitely, right? So only axial force it is removed, right? So here if you are just having this as which one? This gap, na? That is your gap, na? So as you said, right, what happens if the amplitude of this, what is the meaning of this amplitude? That a deformation you can have, na? If the amplitude, if this amplitude is which one? Lesser than this gap, right? Lesser than this gap, right? How many reactions will be there? Tell me. That a number of reactions will be equal to which one? This is 2, na? Number of reactions will be equal to which one? This is 2, you can say, right? So what are these 2? One is shear, one is your bending, na? So one is shear, one is bending moment, right? So if the amplitude is greater than the gap, whenever this amplitude is greater than the gap, means this will go and fill that gap, na? Once it is filling, after that what is that you are having? How many reactions will be there? That a number of reactions will be equal to 3 if you just observe, right? Number of reactions will be equal to 3. So this is for which one? Plane or this space? This is for this plane, na? No. Similarly, amplitude of vibration is nothing but your A is the symbol I am giving. So suppose if that A is greater than this gap, amplitude is greater than the gap, what happens? And amplitude is lesser than the gap. Excuse me. If amplitude is lesser than the gap, right, what happens? You can see it is not filled, right? Except axial, remaining everything will be right. So total out of this 6, 1 axial will be gone. So remaining reactions will become 5, na? So what are these 5? 3 moments plus 2 shears, na? 1 axial only will go, right? So here amplitude is greater than the gap means, right, what it will become? You can say 6, right? 6 means what? 3 moments plus which one? This 2 shears plus 1 axial, na? These kind of things will be there or not? Everyone, right? Note this and tell me. We'll try to move on to the next one. Last support, spring support, we'll try to go for. Note this and tell me all of you. And collar support also will be there. We are having many types of supports, okay? Don't worry. Note and tell me. There in the previous one, fourth one, shears are released, okay? Shears are released. Yeah, thank you, sir. Ramanjal, sir. Okay. Shears are released, right? How many shears will be there generally? 2 shears will be there, no? Yes or no? Those 2 shears will be released, right? So that's why remaining 4 only will be there, right? If it is a plane, na, 1 moment, 1 axial, 1 shear. So only 1 shear will go off, right? So remaining 2 will be there. Here only axial will be gone. So remaining shears will be there. 2 shears will be there as it is, right? Like that, okay? So 2 shears, 3 moment reactions. So automatically what happens? Like that you are having, is not? What and tell me? Mechanism means it cannot, the one which cannot bear any loads, right? It is at the verge of this failure, right? The condition of a structure, whenever it is at the verge of this failure, you call it as a mechanism, right? You cannot use it for resisting the loads, right? That's what is mechanism. Okay, note and tell me. And also we can add one more point under this mechanism and this structure, right? What is it? You can say this structure can be stable, no? The structure will be stable. Yes, it is always mechanism definitely only, right? Because it will be collapsing definitely, no? So mechanism is unstable, right? So unstable means it will not be staying at that location. It will be suddenly falling. It will be moving by larger distance, no? So structure is stable and a mechanism is unstable. Right? You can just add these 2 points also. If you try to add hundreds of points will come, but okay, these are the points important, you can say. Right? You add this. Right. Done? Everyone done? Shall I move to the next support? 6th support, shall we move on to? Right. So 5 supports gets over. Right now we'll be moving on to the 6th support. So what is the 6th support? You can say, right? That is your spring support. There are 2 types of this springs you are having, right? What are the 2 types of this springs? Tell me, everyone. What are the 2 types of this springs you are having generally? One is your linear spring. If member forces are released, then it is a mechanism definitely, right? Other forces, moment release, hinge will be releasing the moment, any axial force released, right? Whatever the force in the member is released, force releases if you are having inside the member, then it is collapsible. That is mechanism for that portion. Okay, linear spring, and what is the next one? Torsional spring. Linear spring and torsional spring, you can say. What is that linear spring? If you just observe, it will be represented like this, right? What does it mean? How many reactions will be having? One reaction only, right? What is it? You can say one reaction only. Are yaar, one second. Are baba. So this one reaction only, right? So number of reactions will be equal to which one? This one only. Torsional spring means, right? How will be representing that torsional spring? Tell me. It is similar to that of your fixed support. It is similar to that of which one? This fixed support, right? Whenever it is similar to that of your fixed support, moment also will be resisted by this torsional spring, right? How it is represented? If you just observe, you can say, you can represent the support, right? Like this, right? So this is how the members are connected to this, na? Yes or no? This is your torsional spring, right? So how many number of reactions you can have for this? 3 number of reactions, right? Similar to that of your fixed only, no? So that's why we are mentioning 3 reactions, right? Next, what is another kind of this support? Tell me. Collar support, right? What is that collar support? You can say, just observe. There is one sleeve like attachment you are having. It can be attached, any member can be attached to this. This is your member, let us say, connected to that. So what happens? For this, you can move in this direction, yes or no? So you can move in this direction and you can rotate it freely. Yes or no? You can move in this direction, you can move in this direction, right? So this axial force will be released, right? That will be released, right? And what happens? You can simply just observe. You can rotate this pin, you can rotate this pin. So what is that? How many reactions will be having? Only this reaction and vertical reaction will be there, right? It cannot move, right? Which collar support, right? A simple pin collar support, right? It is which one? This pin type of this collar support, right? So whenever it is a collar support, okay, one second. 2 types of this collars will be there. One is your pin collar, and other one is your fixed collar, right? So this is your pin collar support, right? Pin collar support, right? What does it mean? Pin means what? Rotation allowed, na? Whenever the rotation is allowed, right, how many number of reactions you are having? Rotation is allowed, this is allowed. So what is it? How many number of reactions? Right? One reaction only will be having na, one reaction, that to this direction, right? RV will be there, vertical reaction. Okay. Now similarly, right, what is the concept? We just observe. Fixed collar support, right? What is the meaning of this fixed collar? Fixed collar means what is the concept? This is your fixed collar, right? For this fixed collar, right, what is it you are having? For this fixed collar support, right, how many number of reactions are possible? Tell me, all of you. It is capable of moving only like this, right? It is capable of moving only like this. It cannot rotate here like this. Okay. What does it mean? How many reactions are there? So it cannot rotate. It cannot move vertically upward downward. Only this axial is possible, right? How many number of reactions you are having? Two reactions are possible. Son, two reactions are possible, right? Like that. Is not? Note this and tell me. Note and tell me, everyone. Done? Others also done? Right. So now coming to this equilibrium. What is the meaning of this equilibrium? You can say equilibrium means what? Net forces will be equal to 0. Na? Net forces will be 0 means no unbalancing of forces. No unbalanced forces, if you just right? No unbalanced forces, right? What is the meaning of this no unbalanced forces? All forces will be balanced. Na? No unbalanced forces means what is it you can say? All forces and reactions, right? All forces will be balanced, right? So I'll write all forces, that is better. So if there is no balancing of these forces, right, what will happen? That may cause a permanent deformation. So all forces will be balanced. So what is that you can see if you just observe? Whole structure. Sorry, whole structure means what? Entire structure as it is now. Whole structure, comma, part of a structure, comma, which one? Any one member, and any joint. Instead of any, we can write every. That would be most effective word. Every member and every joint. So every member and what is it you can say? Every joint must be in equilibrium. So they must be in equilibrium means, right, what is it you can say? They must have to satisfy these equilibrium conditions, na? They must be in equilibrium means what? What is it you can say? They have to satisfy the equilibrium conditions or not? They have to satisfy the equilibrium conditions. You can say, we just observe. So every member will satisfy, every joint will satisfy, and part of the structure will satisfy, and at the same time what happens? Whole structure also will satisfy, right? Like that. Okay. Now you did not get selected. No problem. Try next time. Don't worry. Don't worry. No need to worry about that. So What are the mistakes you have done? Learn from the mistakes and try not to repeat the same mistakes, and try to overcome these mistakes, and you try to do it. Then it is possible. Okay. Next time, this February only you are having na exam. So notification will be getting in February only na. So it is better you start preparation from now onwards. Then you go for it. Okay. Note this. Tell me everyone. Entire structure must be in equilibrium. Entire structure must be in equilibrium. And also which one? A member of the structure must be in equilibrium. Every member and every joint of the structure must be in equilibrium. Right? Like that. Got it? Shall I move to the next? Right. So what is that you can say? Equilibrium equations. Right? What are the equilibrium equations you can say? So there are equilibrium equations that which we can apply for the entire structure. Okay. First one, whole structure equilibrium equations. Right. What is the meaning of these whole structure equilibrium equations? These equilibrium equations must be applied for the entire structure, na? Whole structure equilibrium equations. Right. What is that whole structure equilibrium equations? If we just observe. Okay. So whenever it is that a plane structure, na, every plane structure, right? What does it mean? You can consider any truss also like this. Okay. You can consider which one is only this plane structure like this. So pin jointed plane frame, rigid jointed plane frame, right? And beams you can consider, right? What else you can consider, all of you? Beams you can consider, na? These types of these beams, right? For all these, how many equilibrium equations we are having? 3 equations will be having, na? 3 equilibrium equations, right? So what is that a number of equilibrium equations? Right? 3 equilibrium equations are there. And what are these 3 equilibrium equations if we just observe? Sigma fx equal to 0, sum of the forces in the horizontal direction equal to 0. Sigma fy equal to 0, sum of the vertical forces equal to 0. Sum of the moments about any point, right? Sum of the moments about the support will be 0. Na? Sum of the moments about which one? This is support will be 0. Na? Which is support you can say? Where the moment is 0, right? Hinged support is there, right? Roller support is there, whatever it is, right? These we have to apply on which one? Tell me. On which one? On these external forces. And what? On these external forces we have to apply, and also on which one? This is support reactions, na? On external forces and this is support reactions we have to apply, right? Now what is the second one? You can see if it is a space structure. So for this space structure, how many equilibrium equations you are having? So this is your which one? This is a truss member, na? So this is your space structure, right? Pin jointed space frame. This is your rigid jointed space frame, you can say. How many number of equilibrium equations we are having, right? 6 number of equilibrium equations we are having now. 6 number of equilibrium equations we are having, right? What are this 6 number of equilibrium equations if we just observe? Sigma fx equal to 0. Next, sigma fy equal to 0. Next, sigma fz also equal to 0, na? Is that no? Please increase the volume. I cannot increase the volume. You can only increase the volume. Is it not audible for others? You have to increase the volume, right? I have done with full input, okay, full volume input, you can only increase the volume, right? It is not from my side, you just check it. Patil, Haveri, Karnataka. Right, along with that, what is that you are having? Sigma mx0, sigma my0, and sigma mz also 0 na? Like that, right? These are the 6 equilibrium equations for the entire structure. We have to use it, okay? Note this and tell me. Note and tell me, everyone. Is it working now? Lingaraja Gowda? Did you check your device audio, your device volume, you try to increase, okay? Note everyone and tell me. Right? Done? Clear now, everyone? Anyone having any doubt in this? These are the whole structure equilibrium equations. Yeah, 1 hour class only. 1 hour class only. 1 hour only. Just because we have started at 2:10 now, we'll close at 3:10. Okay? We have started at 2:10, we'll be closing at 3:10. Shruti. Note this and tell me. Now. So what is another one you are having? For the entire structure you can apply on external forces and this is support reactions. Now these equilibrium equations will be applied on which one? This on external forces and support reactions. Don't consider the member forces, right? We should not consider the member forces, right? Now tell me second one, joint equilibrium equations, right? What are these joint equilibrium equations we can apply if we just observe? So at each and every joint, right, how can you apply if you just observe, right? Is not? So whenever it is, which joint you can say if you just observe? Pin joint. Next one is what? A rigid joint if you just observe. So at this pin joint, right? Pin joint means that what are the examples of this pin jointed one? You can say trusses, na? So in this pin joint also that plane truss you can say. Plane truss joint, and what is the second one you can say if you just observe? That is your space truss joint, na? Plane truss joint and this is space truss joint, right? So whenever it is a plane truss joint, na, if you just observe this, so at each and every joint if you consider it, what is that you can apply? Sigma fx0, and what else you can apply? Sigma fy equal to 0, right? These two only we can apply here, right? But if it is this one, na, space wala, then what we need to do? So this is 2, right? Equilibrium equations will be equal to 2. Here sigma fx0 we can apply, sigma fy0 we can apply, and sigma fz also 0 we can apply. Now tell me how many number of equations we are having? 3 equilibrium equations, right? Like that, got it? Now whenever it is a rigid structure also, what is it you can say? If it is a plane structure, na, at this joint if you apply, right, how many are there? Tell me. 3 will be there, right? How many equilibrium equations? That equilibrium equations will be equal to 3, right? What are these 3? sigma fx is 0, sigma fx, sigma fy, and this is sigma m0, right? Now whenever it is a space wala structure, how many are possible? It can be anything, right? Support is not important, right? Support is not required here. That joint is important here, okay? It is not regarding the support, right? Joint, right? Joint is important. Okay? The joint is very, very important, you can say. Sigma mx0, sigma my0, and which one? Sigma mz also 0, right? Is it visible? Just check it and tell me, all of you. I'm just moving a little bit to my left. I am moving, trying to move. Are they visible now? Tell me. Are they visible now? Sigma fx0, sigma fy0, sigma fz0, sigma mx equal to 0, sigma my equal to 0, sigma mz equal to 0, right? Rigid plane frame, rigid space frame. Okay, joints are rigid. When the joints are rigid means they can take the moment also, na? They can carry the moments also, right? Pin joint means they cannot carry the moments, right? Note this and tell me. So here E will be equal to how much? 3 or 6? That is a 6, na? So 1 second, this is 6, not 3. Got it? What and tell me? Tomorrow means next class, it will be next 2 classes will be in the special classes, okay? Day after tomorrow I'll take, right? Tomorrow I'll not take the class, day after tomorrow I'll take, okay? Tomorrow that highway was there, na? That is it. Done? Okay, I'll be closing the session. Anyone having any doubts, all of you? Anyone having any doubts anywhere in our discussions till now? Any doubts anywhere in our discussions right from starting, right? Structure and mechanism, classification of the structure. This course procedure also provide us to solve problems. Yeah, yes, it is mainly for problem solving, na, definitely. So the intention of this one is you have to learn the concept quickly and you can be capable of solving the questions also, right? You could be capable of solving the questions also, right? So don't worry, we will be solving some questions also, right? At least some for every chapter, at least 5 to 10 questions we'll try to solve. Okay, don't worry, 5 to 10 questions we'll solve for every chapter. No need to worry. Okay, clear everyone? Anyone having any doubts anywhere? Shall I close? Okay. So day after tomorrow it will be there in the special class, right? Not in the YouTube. Day after tomorrow this class will be there in the special class. Tomorrow you will be having that highway PYQ class in SSG. Okay. Thank you. Thank you all of you. Have a good day. Thank you.